my screen? If possible, can someone please confirm if you are able to hear me clearly and able to see my screen?
Yes, it's visible, sir.
Thank you. Thank you. Yeah. So before I proceed further today, anyone has any questions on the program point of view? Anyone has any execution issues? Execution side, anyone has any issues? So that I'll take it up first. Otherwise, I'll proceed for the next. As of now, any questions from anyone? Let me repeat, sir. Did anyone has any questions as of now on the program which I shared? Anyone has any execution point of view, execution side, any questions or understanding any questions or testing, how to test? I mean, any point, testing, understanding, implementation, any questions from anyone? Okay. I hope everyone is good. So let me go to the next pattern here, guys. Circuit breaker pattern, guys. There's the next pattern which I want to go, which is a circuit breaker pattern. So this is also very, very useful only in microservices. Maximum, we can think that it is only useful in microservices itself. Okay. So first of all, what is a circuit breaker? What exactly the meaning of a circuit breaker? So that is I want to discuss here. So prior to going to technical details, prior I go into technical details, guys. Okay. I'll take a normal example, guys. I'll take a normal example. Then I'll come back with the circuit breaker, guys. So what exactly the normal example is? For example, sir, in my home, okay, in my home, so I have a bulb and fan. Okay. So in my home, I have bulb and fan, sir. These two are the electric equipment. Okay. Ideally, how the electricity will pass? By default, outside electric junction, right? I call that as an electric pole, isn't it? Correct, right, sir? Outside, what do we have? Electric pole. We have electric pole. Outside electric pole, we have a connecting to MCP. Correct, right, guys? In our house, we have MCP, right? Yes or no, guys? So we have MCP in our house. So bulb controller, as well as fan controller. Bulb controller, in MCP, I have a fan controller. Yeah. So there are two controls I have here, bulb controller as well as fan controller. This is MCP. So electricity flow from MCP will take electricity. And MCP to controller. And MCP to fan controller, right? And from bulb controller to and fan controller to this, right? So this is the actual situation, guys. Yes or no, guys? Now, whenever there is a continuous flow, I have electricity. 24/7 electricity is there. I have 24/7 electricity is there. There is no problem. Understand? If I have a 24/7, 24/7 electricity is there, I don't have any problem. If my bulb will glow, my fan will rotate. Right? Yes or no, guys? Same situation. I have two microservices. Bulb microservice, fan microservice. Okay? These two microservices, if both are up and running, there is no issues at all. There is no issue at all. If both are up and running, there is no issue at all. Correct, right? But if they are not good, something is down or some problem is there, then we have a things here. Correct, right? Now, my requirement is I am working from home. Okay. I need to have a requirement of bulb and fan and switch. There is a one more electric equipment switch I can take. Laptop charging switch. These three things should work irrespective of electricity there or electricity is not there. I don't care. Understand? Sir, I want 24/7. My bulb should glow. My fan should rotate. My switch should work. Then only I can efficiently work 24/7. Correct, right? Yes or no, guys?
How it will work, sir, without?
How it will work without? It's a question. Can anyone answer? Without electricity, for example, sir, in 24 hours, there are 3 hours, there is a power cut. Assuming that there is a scheduled power cut of 3 hours. Assuming that in the afternoon, 1 o'clock to 4 o'clock. and definitely I have a calls in that time only. One day I can tell to my manager, sir, today there is some problem and something, okay? But daily I cannot tell to my manager, right? How it will work? What I need to do?
We have to take inverter.
Correct. Inverter. Correct, right, guys? We need to take inverter. Is that correct? What is the design of inverter? The design of inverter. What is the design of inverter? Any have an idea? So, what I mean to say that here, I will plug an inverter. Okay. So, this is the inverter. But the logic of my inverter. What is the logic of inverter? Ultimately, my bulb and fan, they will take the prime, they should be connecting to inverter. They will be connecting to inverter itself. I can say that this is an inverter. Okay. My bulb and fan should convert to inverter. And my inverter logic is primary and secondary. Primary part as well as secondary part. Primary path as well as secondary path here. So by default, what exactly the logic? Always inverter primary path is to take from the electric pole. To take from the electric pole itself. My primary path of this is to take from the electric pole itself. That's a primary path. It's a primary path always. And secondary path is battery. I'm going to have a battery. I'm going to have a battery here, which also produces some type of current. AC current or DC current. I don't know what type of current it is, AC or DC. So I'm a little bit weak at about electricity, but it will produce some current. The logic of inverter is end user point of view. I'm an end user. I'm using bulb. I'm using fan. I'm using switch. My perspective is I no need to look back. Is power is gone? Do I need to do anything? Is power is back? Do I need to do anything? Nothing. I should have a uninterrupted power supply where my bulb and fan should rotate. With the logic of inverter logic is always inverter should health check. Inverter do health check with what? Power supply from pole or power supply. Why pole? power supply to MCP. I don't want to go to pole word. Do a health check with a power supply to MCP. This is the inverter should always continuously. I don't know the algorithm. Inverter should do a continuous continuous health check. Do a health check with the power supply at MCP level. It will do a health check. At MCP level, they do a health check. Whenever it feels that, it will do a health check. During health check, if power supply is there, during health checkup, if power supply is there, always, if if health check is good, if health is good, health check is good, take the power from MCP. Take the power from MCP. If health is good, it is going to take the power from MCP. Assuming that power is gone. Assuming that power is gone. If health is or health check is failed, if health check is good or if health check is failed, what we need to do here? Alternative path. Alternative path enables the alternate path. What is the alternate path here? Power from, it will take the power from battery. It will take the power from battery. Automatically, inverter will be shifting the route. Whenever there is a problem in the main supply, whenever there is a problem in the main supply, it will power off the, it will close the main circuit. This is the main circuit they can call. It will close the main circuit. It will enable the alternate path. It will take the power from the battery. And bulb will glow, fan will rotate, my switch will work. My bulb will glow, my fan will rotate and switch will work. Okay. So what exactly the algorithm here, guys? What is my main algorithm? Primary path is MCP, right? The main logic is here. Primary path is MCP, main flow, main control flow. And secondary path or fallback path, anything I can use, is battery. And secondary path is battery. Main path is MCP. That's a primary path. Battery is a secondary path. So, sir, first it will check and main power is there. Bulb will take the power from MCP and it will glow. As long as it is able to find, okay, where there is no power. If there is no power, as long as it is able to find, automatically it will within a fraction of few milliseconds, a small flickering, user will observe, but very rare case, small flickering will happen. User will check, automatically it will take the power from battery and the bulb will glow, fan will rotate. But once it takes from the battery, is it permanent? No. It's only an alternate path or a fallback path. And it always monitor the health check of the MCP again, even though it is taking the power from the battery, but it will not stop it health check. It always continuously do a health check. It always do a continuous with health check. As long as my power is coming, as long as power is coming in MCP, then it will stop the alternate path and it enables the main path. So with this particular logic, MCP logic, inverters are working perfectly. I mean, inverter logic with this inverter logic. So there is a good success rate with home. I mean, all those good rate, okay, where everyone can take and they can use. Okay. So what is the logic here? My inverter is having two paths, main path, alternate path. First focus is main path only. My first focus is on main path only, guys. Okay. If at all, if my main path is having problem, then I will take the alternate path. And once I take alternate path, it's not permanent yet. I'll take again do a continuous health checkup of main path. Again, I'll do a continuous health check of main path. Then, if main path is down, it will go to secondary. And if the secondary is good, and once main path is back again, then it will stop the secondary path. It will enable the main path. This is a logic which everyone is aware. I no need to teach extra thing here. But is that correct? Do you understand? Do you got whatever I'm trying to say here, guys? Everyone is clear on this things actually? Everyone is clear, right, guys? On this logic. Okay. The same pattern we are going to achieve in microservices. In microservices, I have same. Okay. Who is my client? Bulb is my one client. Fan is my another client. Switch is my another client. Okay. Bulb is one client. Fan is another client. Switch is another client. Total, I have 3 clients. What I need here? Electricity I need. Electricity I need. Bulb is some amps. Fan is some amps. Switch is some amps. Some voltage, different voltage. But we need the main power. Okay. So what I'll do here? I'm going to connect directly to the microservice. If I'm directly writing logic, okay. If I'm directly writing logic of, always I'll get the power and I'll utilize that power to my bulb. I will utilize my power to, okay, one second, guys, one second. So by default, what is the point here? If I take electricity from outside and bulb will take it, fan will take it, switch will take it. But whenever there is no power coming, then I have a problem. So if I have no problem, if I have no power, if I directly connect, right? Then there is a typical problem we have, guys. Understand, right? So what is the problem? If the power is not there, these two electric equipments will not work. What I need to do here? I need to connect bulb and fan will connect to inverter. They should take the power from inverter, and that inverter will connect it to MCP or battery. That's it. Then I can confidently tell that my fan microservice, my bulb microservice, my switch microservice, 24/7 it will be working. 24/7 it will be working. Correct, right, guys? Will you agree to my point? Primary path is from electric pole, secondary path is from battery. Is this giving 100% solution, guys? Is this particular pattern or is this particular design or is the solution giving 100% solution? I mean, this, what I can say, this approach is giving 100% solution. There are some limitations are there, but when I compared with advantage versus limitations, I feel more advantage. I'll feel less disadvantage. What are the limitations? Sir, first of all, before I go to limitations, is everyone is clear? Any questions here on this approach? Anyone has any question, guys? I hope everyone is able to hear me clearly, right? There is no problem in my side, right? In voice and screen. Sir, anyone can respond to me, please, if you don't. Yeah, everyone is able to hear me clearly, right?
Yes, sir.
Yeah.
Good.
Okay, thank you. Just I thought of checking. Anything is okay. Right. What are the limitations in this framework? The first, anyone can take limitations. This is not a technical, right? Our own, right? What are the limitations here? No limitations at all? Can be applied to not all for electronic equipments. For all electric equipments, can I apply? Okay. Or else I can say low power consumption points only. I can apply. Is that correct? Can I apply my inverter to AC? Can I apply my inverter to geyser? We can apply this logic or this approach only for those which consumes less power. Not for geyser, washing machine, AC. Sir, inverter AC is different, sir. Don't compare inverter AC. Okay? ACs, we cannot apply. Can I apply this to all the electronic equipments? Electric equipments in my home. Can I apply this inverter for all? Can I call this as a limitation or not? Is it a limitation or not, guys?
Yeah, it's correct. Exactly correct. You won't apply
Exactly.
washing machine AC only
Yeah.
for bulb and fans only.
I mean, low consumption. I mean, anything we can apply, but low consumption. I mean, less power consumption, which will take less power. Second, always secondary path should not fail at all. Always my battery should be working. My battery should be in working condition. Always my battery should be in working condition. Will you agree me?
Yes.
Assuming that my battery is not working, even though logic is superb logic, it will check the primary path and it's not there, it will go to secondary path. If secondary path also there is no power, if my battery is having a problem in inverter, battery is gone, will you get a power supply? No, right?
No.
What is the limitation? If at all my secondary path is having a problem, then this approach will not work. Always secondary path should not fail at all. Means we need to design fallback path or secondary path. We need to design a fallback path in such a way that it should always working in, or it should in such a way that it should not fail again. It should not give any exception, error, etc. Can I decide like that? I should decide. That is the main point here. I cannot apply to all things, but I can apply this. These are main limitations. Are any other limitations, guys, on the inverter? I feel that these are the two limitations. Apart from that, no limitation at all. These are my points related to this inverter. But with these limitations, can I take? Yes, I can take. Exactly, I can take. Why? Sir, in my home, power will be 24 hours, power will not go. Maybe 1 hour or 10 minutes, alternate times power will go. Correct, right? 24/7, my power will not have any problem at all. Am I right? So only few in a day, 2 or 3 or 4 times. That's it. So during that situation, my main system, my main usage, bulb and fan and switch in every room. In every room, in living hall, bulb and fan and switch, in bedroom, living hall, fan and switch, and in kitchen. So I'll take minimum electrical points in every room and I'll convert that to inverter. So whenever there is a problem, I'll take the power from the battery and they will work. So my day-to-day activities will not stop. I can go, my day-to-day activities will never stop. AC, the washing machine, geysers, all high consuming electrical points, I will not use highly. 24/7, I cannot use them. Can I make AC like 24/7? No. Washing machine? No. Geyser? No. They will not that much the frequency of usage when we compare to electric bulb and electric fan. So first limitation, I'm okay. Second limitation, I'll make sure that my battery, I'll take a battery which is a tall tubular in design, which has a good warranty, and I will use as per the guidelines, whatever the battery companies will tell, and I'll use in such a way that it will be giving long life to my things. Then if these two limitations are there, I can use it. Everything same applies to microservices. Everything, whatever I mentioned here, same applies to microservices. There is a point not one difference is also not there. Where every microservice, I have a bulb microservice, fan microservice, switch microservice, AC microservice, geyser microservice, like that. Okay. Every microservice requires power. But if power is not there, my main flows in every product, there will be certain critical main flows. I will convert to an inverter, which is called as a circuit breaker. I can call that as a circuit breaker. Inverter is called as a circuit breaker. Okay. The main path. What is the main path? The actual microservice logic. The actual microservice logic is main path. Order service, order creation, payment service, payment creation, shipment service, shipment creation, return service, return logic, something like that. I am going to have the main logic. Okay. And alternate path. I will create my alternate path. It's my design. Fallback path is my design. But conditions apply. Whatever the design you are taking for fallback path, it should never fail. That is the design you should take it. 90.999% it should never fail. If it fails, there is no logic of your inverter. It's not a workable model. Nowadays, everyone is taking inverter because these 2 points are good and we can work with. In the same way in microservice architecture also, I'll take a circuit breaker as a design pattern, which is similarly matching to my inverter logic. Circuit breaker is a design pattern, which is matching similarly like a inverter design pattern, where my primary path is actual microservice. Actual logic of my microservice is primary path, and secondary path or fallback path or alternate path, whatever you can call that as a synonyms, alternate path or secondary path or a fallback path. It's your choice. Any logic you can think of. It should always should be running successfully. I mean, it should not give any error. With that logic, I can apply circuit breaker. Is it correct? Yeah. Is that correct, right, guys? Any questions here as of now?
Can fallback path can be a retry of the primary instance, like
By
primary?
default, madam. By default, madam, you no need to apply. I mean, am I writing any law? I mean, in inverter, in fallback path, why? Just like a logic is, okay. Again, a continuous health check with main path. A continuous health check of main path. For example, madam, assuming that 1 minute power is not there, madam. Just like I think of scenario, 1 minute power is not there. Okay, madam. So what happens here? As long as power is gone, automatically it will connect to battery. Okay. In that 1 minute also, it will do a health checkup. As long as it is taking a health check, it says that power is back. Immediately, it will take the power from it will disconnect the alternate path, or it will disconnect the battery, and it enables the main path.
Okay.
So, by default, inverter has the logic. That's what I told, right? Continuous health check, do health check. If the health check is failed, enables the alternate path, and again it will poll the main path. Is it back again? Is it back again? Is it back again? It will always check the main path. So in the same way, I can design my real micros. In the same way, I can design my microservices. Same approach without any difference. Sir, this is the only one architecture in IT industry which is exactly matching with day-to-day design pattern. I mean, in our day-to-day, whatever the design, I mean, design pattern means solutions, right? In our house, inverter is the problem to a solution, right? I can apply 100% without a small deviation also. Whatever the logic of inverter, I can apply in real time in my microservice architecture. And this is only works for microservices. Why? In my house, I have a MCP. In that, one control for one room, one control for one room, one control for one room. I can segregate at each switch level, at each bulb level. I can do that. Correct, right? My internal home wiring is a microservice. I can switch off all the MCPs. I can only switch on one MCP. All those things I can do that. I mean, just like I'm giving. So similarly, I can apply this logic. Any questions, guys, as of now? As of now, any questions from anyone, guys? I hope everyone is good, sir. Okay. Sir, tomorrow I will take till 8:15, sir. Tomorrow 8:15 to 8:20 I will take, sir. Okay. Because this today I'm stopping, and today's 15 minutes I'll compensate tomorrow, sir. This daylight savings killing me. Okay. So today's 15 minutes, I'm stopping 15 minutes, right, sir? Can I take tomorrow extra 15 minutes, 7 to 8:15? Is that okay with everyone? 8:15 to 8:20? Or you have any tomorrow anything, sir, there? Is everyone is comfortable for only tomorrow? Okay, I hope everyone may be comfortable. Else not, you have a video is there. Okay, fine, sir. Thanks everyone here today, and we'll meet tomorrow. Tomorrow
Sir,
my
tomorrow,
topic is
tomorrow 8:15, sir.
no, 7 to 8:20, same timings.
Oh,
Extra
okay.
20 minutes I'll take because I'm stopping early, right?
Yeah, no problem.
Yeah, today I'm stopping early, tomorrow, okay? So tomorrow's my agenda is limitations of circuit breaker and resiliency 4G. There are two design patterns. I'll explain that. Then we'll go into the living session. Okay. Thanks everyone. Have a great day.